Welcome to the another lecture of a data science playlist. In this lecture, we will cover the topic dimensional reduction in data science and what are the needs for a dimension reduction in data science and how to identify the multicollinearity using Python and the principal component analysis, etc. Now, starting with the dimension reduction in data science. Dimension reduction in data science refers to the process of reducing the number of features or variables in a data set. It means that whatever the data set we are using, we want to reduce the features and variables on that data set. So we use dimension reduction while retaining as much information as possible. It is a technique used to simplify model, improve performance, reduce computational cost, and prevent overfitting by eliminating redundant or irrelevant data. So now next, what is the need for a dimension reduction? As we have already studied many things in our definition, that we want to increase the features and variables and eliminate the reduce the cost, computational cost, and want to eliminate the redundant or irrelevant data. Now, another need is that multicollinearity. Typically, large database have many predictors. It is unlikely that all of these predictors are uncorrelated. It means that in a large database, many of the predictors are not related to each other, but they are present in the data set. So we want to remove that type of a data. Multicollinearity, which occurs where there is a substantial correlation among the predictors, can lead to unstable regression model. In simple terms, we can understand multicollinearity in such a way that multicollinearity refers to the some items that are present in a large database which are unrelated to each other. Now, moving to the next need, double counting. Inclusion of a predictor which are highly correlated tends to overemphasize a particular aspect of the model. That is especially double counting this aspect. For understanding this, we take an example. Suppose we are trying to estimate the age of a youngster using maths knowledge, height and weight. Since height and weight are correlated, and the model is essentially double counting the physical component of a youngster as compared to the intellectual component. Here, in example, we are using height and weight. They both are correlated to each other. Here is the case of a double counting of a physical component. So this is also one of the another. There is also a need for a dimension reduction, which is a mathematical dimension reduction. Now understanding the another need, curves of dimensionality. A dimensionality increases the volume of a predictor space grows exponentially, that is faster than the number of a predictor itself. Thus even for a huge sample size, the height dimension space is sparse. For example, the empirical rule states that about 68% of normality distributed data lies within one standard deviation of the mean. But there is for one dimensional, for 10 dimension, only 2% of data lies within the analogous hyposphere. So here we want to a reduction dimensional reduction in our shape. So this is one of the another need for the dimension reduction. Now, after knowing the needs, how to identify the we will study that how to identify multicollinearity using Python. Mm, to identify that, first we need to required to import all the packages required for that code, and now we will understand uh, what are the steps required for multicollinearity. The first step is correlation matrix. We need to make the correlation matrix of our data set. Whatever data set we choose, we need to make the correlation matrix for this. Check the correlation between the independent variables using a correlation matrix. High correlation values close to 1 or -1 between any two variables suggest multicollinearity. Now the second step is variable inflation factor, which is represented as a VIF. Measure VIF, how much the variance of a regression coefficient. Now, understanding it in a theory, we will go to our Google Colab and see how we can understand by the code. As we have studies, we need to import the required packages. We have imported the required packages and we have load our data set, which is California housing test.csv file. We have copied the path, and as we have studies, our first step is correlation matrix. So we have created here the correlation matrix, and our second step is variance inflation factor. We have measured here the uh, variance inflation factor. After that we get the correlation matrix, which is look like that, which is somehow look like that. So this was all about how to identify multicollinearity using Python. After this, we move we move on the principal components analysis. So now that we have identified the multicollinearity among our predictors, what do we do now? We When we have too much overlapping information, we use PCA. It means that if our previous steps do not work, we have a lot of overlapping, then we need to use PCA. PCA means principal component analysis. Um before understanding the PCA in deep, firstly we need to understand what are the applications of a PCA. So the applications of PCA are dimensionally reduction. It is used PCA used for dimensional reduction. We have already studies that what dimensionally reduction exactly refers to, and noise reduction, and data visualization, and pre-processing for machine learning models, anomaly detection. So this is also type of a dimension reduction, which is further used after we see the much overlapping in our data set. So this was all about the dimension reduction in our data set. Uh, Thank you so much.